Hello, this is the first of a set of videos that I'm making for my data abstraction class. This class is taught in C++, and one of the most important concepts that students need to understand coming into the class is pointers. They've done their previous work using the Scala programming language, and Scala, like other managed languages, doesn't have real pointers in it. And it's essential that they understand what pointers are, how they work, and the syntax that's associated with them. So I wanted to make a few videos to walk through that. So let's start off by just talking about memory and variable declarations and the like. So in C or C++, you can declare a variable by doing something like int a equals 42. That's lowercase in C++. And we end it with a semicolon. And what this line of code does is it creates a chunk of memory. It stores the value 42 in that memory, and it gives it the name A that we can use to refer to it. This would be happy in C. In C++, starting with C++ 11, it is recommended that we add some curly braces, and indeed we can even get rid of the equal sign to use the curly brace initialization. So kind of as a mental image that you might have if you are thinking about what this actually does is something like this. So we've created our variable A, and it stores inside of it the value 42. So where do pointers come in? Well, pointers, as the name implies, point to memory. So if we declare a pointer that is, say, it has the name B, we'll go ahead and make our B. And what gets stored inside of B? Well, turns out the answer is not 42. The answer is a memory address to the thing that this points to. So if I make B point to A, B stores the address of the variable A. Now, of course, addresses are just numbers. The memory of the computer is laid out linearly, and so you can picture the memory for your program as being one long block here. In reality, when we declared this A, what really happened was that we got a chunk of memory here. Oh, darn it. And it is called A. And our memory is broken into two parts. We have a stack and a heap, and the stack is nice and orderly, and every time we call a new function we get a little bit more memory allocated on the stack, and when the function returns, that memory is freed up to use for the next call. So what happens to this arrow and our B if we make a pointer to A? Well, in reality, what's going to happen here is that B is also going to sit here on the stack. And the thing that we represented as an arrow is really, here's a question, how well can I draw this? So we represent this as an arrow that points from B to A. In reality, this is going to store some number inside of it. And we would normally write this number in hex. Let me drag this way over here. Who knows exactly what it will be like? We can play with this in a following video. Okay, that works. Oh, no, let's add one more digit. There we go. So I made this so that it has 8 hex digits, which would be a nice 32-bit value. And this would be our B value, assuming that the value A was located in memory at this address. Okay, so pointers are just addresses, like having the address to someone's house or someone's email address. It's how you get to them. Okay? So we're storing that in B, and really at a fundamental level, that's all that a pointer is. So we'll come back in the next video. We'll talk about how we can get these pointers syntactically in C or in C++, and we'll also look, instead of me just making up hexadecimal digits here, we'll actually look at the values for some pointers.